Good afternoon. Today we're going to talk about a general class of compounds related to alcohols called sulfonates and some related compounds. As you know, the chapter we are currently doing is a chapter on reactions of alcohols and preparations of alcohols. Well, sulfonates are related to that in that they can be made from alcohols and also turned into alcohols. Before we specifically see the relationship to alcohols, though, we need to learn a few new classes of compounds and how we name them. They're all related to each other and it's not very hard, but these are whole classes of compounds, and we'll have specific examples of each one of the classes and learn about the names of the specific examples, as well as some special symbols that we use to represent those compounds. So let's just start with compounds that have the S double bond O double bond O OH group. So far it looks kind of like sulfuric acid. If we have another OH on this side of the sulfur, then that is sulfuric acid. That would be H2SO4. You can imagine what that would look like. But if instead of an OH on the other side we have another carbon group, I'm going to use the R to represent a carbon group, that would be what we refer to as a sulfonic acid. So that's a class of compounds called sulfonic acids. Notice that they're kind of similar to carboxylic acids. If instead of the S double bond O OH group, we had a C double bond O OH, that would be a carboxylic acid. So sulfonic acids are kind of related to carboxylic acids. In terms of the strengths of the acids, as you know, carboxylic acids are weak acids. Sulfonic acids, being very similar to sulfuric acid, are strong acids, but they are organic compounds because they have a carbon group in them. They're the strongest class of organic acids, called sulfonic acids. Okay. Now, related to sulfonic acids are the conjugate base of sulfonic acids. If you think of this as an acid, which it is, and we take off an H plus from that position, replace it with a negative charge, so we have an O minus instead of an OH, that being the conjugate base of the sulfonic acid. These are known as sulfonates. So this is then a sulfonate compound. Of course, being a negative ion, there has to be something positive to balance it out. So sulfonates themselves don't exist without something positive, like you can have sodium sulfonates and calcium sulfonates and ammonium sulfonates and so on. A third category of compounds related to those are the category where the negative oxygen is replaced with, or not replaced with, but substituted onto another carbon group. So we have two carbon groups in this kind of compound. One is the original carbon group that's on the sulfur and all of these on the sulfonate group, and then we have another carbon group on the oxygen on the other side of the sulfonate. These are actually examples of esters. This is known as a sulfonate ester. Okay, now you may be thinking, if you're on the ball, wait a minute, Dr. Armstrong, it doesn't make sense because we already know what esters are, and esters are compounds that have C double bond O, O-R, and this has an S double bond O with another double bond O, and then an O-R. This is a different kind of ester. The kind of ester you're used to is called a carboxylate ester. So let's just compare. In fact, let's compare all the way down the board carboxylic acids and their related compounds with sulfonic acids and their related compounds. So if we have C double bond O, OH, that's a carboxylic acid. If we have C double bond O negative, that's a carboxylate. And if we have C double bond O, O, R prime, that's a carboxylate ester. Oops. So you can see the relationship between carboxylic acids and their related compounds and sulfonic acids and their related compounds. Now carboxylate esters are way more common than sulfonate esters, and so if you hear the term, quote, ester without any modifier in front of it, then they're referring to a carboxylate ester. But technically, if you say the word ester, you should indicate whether you're talking about a carboxylate ester or a sulfonate ester. But again, if you don't have any modifier in front, then it's assumed that it's a carboxylate ester. Okay, well that's all well and good, but we are currently interested mostly in sulfonates and their relationships and other related compounds. So we'll just take the carboxylates and their related compounds off the board for the moment and focus on the sulfonates. Okay, there's yet one other class of compounds related to these, and I'll draw it above, and that is still having the R, S double bond O, but instead of an oxygen, as the three of these have, it has a chlorine instead. And as you know, this is kind of like an alkyl halide, this is kind of like an alcohol in the sense that you can replace chlorines with OH groups. Same thing is true for sulfonates. This class of compounds where you have a sulfur-chlorine bond, direct sulfur-chlorine bond, those are known as sulfonyl chlorides. A sulfonyl chloride. Okay, so four new classes of compounds: sulfonyl chlorides, sulfonic acids, sulfonate ions, remember part of an ionic compound, and sulfonate esters. What we're going to learn is that each of these can be converted into the others in various ways. Important, specifically the sulfonate esters, are important to alcohol chemistry. Okay, let's learn some specific names. There are many, many possibilities under all of these because, as you know, R can be lots of different things. But normally you don't see very many different R groups in this context. The ones that you will see most commonly are, and I'm going to go ahead and use the sulfonic acid, but the rest of them obviously are related. We could have a methyl group directly attached to the sulfur, in which this is called, the specific name of this compound is methane, no space, sulfonic acid. Methane sulfonic acid. Notice that the word methane is in there. We think of methane as being CH4. Well, here it's a CH3, which we would normally think of as being a methyl group. And so you might say, yeah, but shouldn't that be called methyl sulfonic acid because it's got a methyl group on it? Perhaps so, but nevertheless, this is what people call it. It's called methane sulfonate, or methane sulfonic acid. Okay. So given that, what do you suppose the name would be if we took off the hydrogen and replace it with a negative charge? Well, this is methane sulfonic acid, and it's a sulfonic acid. We want to turn it into a sulfonate. What would the name of it become? Methane sulfonate. Get the pattern there? And if we turned it into a chlorine instead, sulfur, then what would the name of it be? Well, it's obviously a sulfonyl chloride, so what's it going to be? It's going to be methane sulfonyl chloride, all one word, methane sulfonyl chloride. And that's the specific name of that compound. So clearly, if you know the name of the sulfonic acid, you can name the other categories from it. Now, one that we haven't mentioned yet is the sulfonate esters. How do you name them? Well, they're a little bit different because they have not only the sulfonyl group, which is this group right here, but they also have another carbon group on it. So we have to figure out how do we indicate what that carbon group is. So I'll go ahead and give you an example, and we'll work out the name together, and then you can use that as a pattern for naming other categories or other compounds of that same category. So what are we going to call it if we have, let's say, again a methyl group directly attached to the S double bond O, and then another oxygen, just like we have there. By the way, that oxygen is very important. If you put another carbon group directly attached to the sulfur, then it's a completely different class of compounds, known as sulfones. We're not going to deal with sulfones at all, so make sure you put another oxygen in there. And then have another R group, let's say an ethyl group. What are we going to call this compound? Well, the way you name esters, and we haven't learned about naming carboxylic esters yet, but basically it's going to be the same system when we do. What you name first is this group that's attached to the oxygen. In other words, the R prime that's on the oxygen part of the sulfonate. You name that first. So we say the word ethyl in this case. And then we leave a space, and then we name the rest of the compound just exactly as if it were an ion, negative oxygen. So what was that called? That was called methane sulfonate. So this specific compound having an ethyl group on the oxygen and a methyl group on the sulfur is called ethyl methane sulfonate. Now I think you may see why we don't put a methyl in there. We call it methane because it would be very confusing to have ethyl, methyl, sulfonate. Both of those would seem to be equivalent, but it's really important to realize that the group on the oxygen is separate, got a space in it, and it has the YL ending. The group on the sulfur is all part of the same word, doesn't have the YL but has the ANE ending. So just for practice, what would it be called if we had the methyl group on the oxygen and the ethyl group on the sulfur? Well, then it would be called methyl ethane sulfonate. Okay? In other words, this part really is considered to be all one group. That's why this is all one word. And then the group on the oxygen is sort of a separate part of the molecule, so it's got a separate name, which is always given out in front. Okay? So let's just quiz and do another example. What would we call a compound if it were a benzene ring with a directly attached to the sulfur, double bond O, single bond O, and then let's just put a CH, CH3, CH3. What are we going to call that compound? Well, remember the rules for naming sulfonate esters is you name the group that's attached to the oxygen first. So what is the name of that group? A 3-carbon chain attached in the middle. That's an isopropyl group. So we're going to say the word isopropyl first. And then we name the group that's attached to the sulfur, but we don't use the YL ending. We use the name of the whole thing itself as if it were a separate molecule. So what is the name of just a plain benzene ring with nothing else attached to it? It's called benzene. So we just say the word benzene. And then all together, no space, sulfonate. So this particular compound, specific name, isopropyl benzene sulfonate. Right? And just for completeness' sake, what if this were not an oxygen but a chlorine instead? So this whole thing is replaced with a chlorine. What would that be called? I won't write it out here, but that would be related to this class of compounds. It's now a sulfonyl chloride, so this would be called benzene sulfonyl chloride. All one word, except for after the YL, there's a space before the chloride in those compounds. What would we call it if that had an OH on it? Benzene sulphonic acid, this category of compounds. And what would we call it if that were an O negative, conjugate base of the sulphonic acid? Benzene sulfonate ion. And of course that, as we've said, would have to have something positive to balance it out. So it might be sodium benzene sulfonate or calcium benzene sulfonate or whatever. Okay, so now you know how to name and categorize these 4 classes of compounds. Let's now talk about some 2-letter abbreviations that are very common, specifically with certain kinds of R groups that you can have on these compounds. And what do I mean by a 2-letter abbreviation? Well, you may remember that certain groups in organic chemistry are so common that rather than writing out the formula of the group each time, chemists just have decided, we're going to use a shortcut, we're going to use a two-letter abbreviation, much like the element atomic symbols on the periodic table. So what does it mean if you have Me? Clearly that's short for a methyl group, so that's CH3. Et, short for an ethyl group. Pr, short for a propyl group. Here's a little exception, small I, P, R. What does that stand for? Isopropyl, so that would be the CH3, CH3, point of attachment in the middle, and so on. You have lots of other individual groups that are given two-letter abbreviations, sort of like, as I said, atomic symbols on the periodic table. Well, there are a couple of other ones that we've seen. Earlier on, we learned about the AC group, capital A, small c. That is the CH3, C double bond O group. Okay, so called an acetyl group, and AC is the two-letter abbreviation that we often use for that group. Okay, what does that have to do with all of these various sulfonates and so on? Well, there are some of these that are so common that they're abbreviated much in the same way. In fact, the methane sulfonyl group, that's the methyl group with the sulfur and its two oxygens attached to something, whether that something is a chlorine or an OH or an O- or an OR. This whole group right here, but not including an oxygen, is abbreviated MS, capital M, small s. Why would that be true? Because the name of this thing is methane sulfonyl, and so MS for methane sulfonyl. Similarly, a benzene ring attached to a sulfur with two oxygens and then attached to something else, that group, not including an oxygen or the chlorine, but including the sulfur and its two oxygens, is benzene sulfonyl chloride or sulfonate or whatever, so it's usually abbreviated as BS. Nice little abbreviation there, BS, for benzene sulfonyl. Then there are a couple of other ones that are even more common, and that would be, for whatever reason, a very common example of a sulfonate is one that has a benzene ring and then a methyl group on the opposite side of where the sulfonyl group is attached, and that whole thing, including the methyl group and the benzene ring and the sulfur group, is known as TS, and that stands for toluene sulfonyl whatever, so toluene sulfonyl, and the reason the toluene name comes in is because a benzene ring with a CH3 group is called toluene. It's a very common solvent. In fact, we used that first semester in one of the laboratories. We used toluene. Well, this is toluene sulfonyl, and so TS is the abbreviation that's used for that. And then there's another one that's very common, and it's related to the methane sulfonyl that we saw a minute ago. And that is if you have a CF3 group, not CH3, but CF3, and then the sulfur double bond O, and then the group attached, whatever group happens to be attached to it, whether it's a chlorine or an oxygen group. This whole thing is called trifluoromethane sulfonyl. I'll write that out. Trifluorosulfonyl. We'll just leave it at that because that may be sulfonate or sulfonyl, depending upon which of these classes of compounds it is. And its three-letter abbreviation is TF. Sometimes it's shortened to triflyl. Whether that's triflic acid for that category of compounds, or triflate for that category of compounds, and as well as this category of compounds, or triflyl chloride for that category of compounds. That's really just a contraction of trifluorosulfide, the name, but TF is often used for that particular one. So I think that's where we'll stop today. You have learned 4 new classes of compounds. You've learned how to name individual examples of those classes of compounds, and then you've learned some 2-letter abbreviations for specific examples of each one of those 4 different classes of compounds. So thanks for listening.